The melting point of a pure compound is a characteristic physical property, meaning that it remains constant under specific conditions. When impurities are present in a substance, they can cause a depression or broadening of the melting point range. In general, a higher melting point indicates a higher degree of purity. Pure substances typically have a sharp and narrow melting point range, whereas impurities can cause the melting point to decrease and become broader. This is because impurities disrupt the regular arrangement and bonding between the molecules or ions in the substance, making it more difficult for the compound to form a solid lattice. When the crystal lattice containing impurities is melted, the presence of impurities can alter the melting behavior compared to a pure crystal lattice. In summary, the melting point of a substance is directly related to its purity. A higher melting point and a narrow melting point range indicate a higher degree of purity, while impurities cause a depression in the melting point and broaden its range. The relationship between melting point and purity is essential in chemical analysis, quality control, and the identification of substances. The graph below shows how the temperature changes with time as a substance is heated at a constant rate. There are obvious horizontal flat sections of the graph at the melting and boiling point called plateau. Below the melting point the substance is a solid. Above the melting point the substance is a liquid. At the melting point, although the substance is still being heated, there is a time when the temperature does not change, remains constant, and the graph is horizontal. During this time, all the extra heat which is being added goes to overcome the force of attraction, the bonds, between the particles of the solid as it turns into a liquid. The process of melting requires extra energy, it is endothermic. When all of the solid has melted, then the temperature of the liquid will start to rise.
Right, the previous video you just watched explained the theory behind everything that you're going to be carrying out in this experiment. And that's basically determining the melting point of a solid, precisely benzoic acid. So you'll be given a dried sample of the benzoic acid. If it is not dried, you have to dry it. Then you have to crush it if it is not ground. So when it's crushed, just take 0.1 gram of that sample, introduce it into what we call a capillary tube. The capillary tube looks like this. Okay, you introduce 0.1 gram into the capillary tube and tap it such that it goes down to the bottom of the tube. Okay, now you're going to insert this into the melting point apparatus. The melting point apparatus, if you look at the setup in your manual, you get to see it there. So once you insert it into the melting point apparatus suited with a thermometer, you get start heating. Of course, the melting point apparatus tends to hit the sample such that it melts. Okay, once you get to observe the first initial melting sign, you note the temperature. If it's melting probably around 107, you notice that something is happening. Yes, it's turning into the liquid phase, from the solid to the liquid phase, that it's melting. So you keep observing till the whole content in the melting point apparatus is completely melted. Then you note the second temperature, that is T1, T2. Now the range of temperature is the melting point. Now again, you have to repeat that experiment for like 3 times to get an average value. Then you now comment relating your results with that of a literature. What do I mean by literature? You could just browse what is the melting point of benzoic acid, then compare it with what you have as your result. Okay, then comment based on, draw conclusion based on the purity of the substance. If you get to watch the previous video, you get to see how it has been explained, how melting point affects the purity of a substance. And I basically explained that too because these impurities tend to break down the cohesive force between the particles in the substance itself. So how does these impurities get to affect the melting point of that substance? It can cause the melting point of that substance to actually get depressed. What I mean by getting depressed is lowering the melting point. Okay, and this is just because those impurities tend to disrupt the crystal lattice of that particular substance, in this case benzoic acid. Okay, it actually makes it easier for the molecules in that particular substance to escape or turn into the liquid phase immediately, because the bonds are not well held. So the impurities tend to destruct the crystal lattice of the solid structure, making it more prone to melting, and that is how impurities tend to depress the melting point. You will see the melting point is well depressed. That means it is well lowered. If a substance that should melt at 100 is now melting at 90, that is due to the presence of these impurities. And in another case, you get to see that the melting point is actually broad. What I mean by broad is the range. If a pure substance should melt at 100 to 150, but due to the presence of an impurity, you get to observe that that same substance will melt from 100 to 200. So it's melting at a very broad range of temperatures. That's telling you that there's an impurity in that particular substance. It is no longer pure. So we talked about depression of melting point and the broadening of the melting point. So broadening means a wider range of melting. All right, it is not well defined. The melting point is well broad. So if substance A, in the first instance, if substance A has a melting point, should have a melting point, let's say 100 to 120, okay? But that same substance, you know that the literature value is 100 to 120. But if your result is probably around 90 to 100, that is a depression. That is telling you that that substance is possess some degree or some amount of impurities in it. So that is depression. It is not having that exact melting point. It is lowered. It is depressed. So, and if that substance again should melt at 100 to 120, instead of melting at that range, it's now melting at 100 to, let's say, 150. You see, the melting point is broad. So that tells you that there's an impurity. So it should have a narrow melting point range and should not be lowered. So that is the effect of impurities basically. So the previous video you just watched should give you more insight on this particular experiment, determination of melting point of benzoic acid. Okay, just try to follow these procedures clearly from your manual, and then you should be able to draw a very good conclusion based on the purity of the substance and how impurities tends to affect the melting point of a substance.